A silicon nanowires biosensor is a solution to pollution detection with reference to environmental contaminants.
In this modern era, environmental issues is undeniably done by the advance of technology, thus environmental monitoring is very important. It is very helpful to those taking decisions for environment because the results of monitoring can be reviewed, analyzed statistically, and published. Biosensor has been getting more attention as it gives greater sensitivity and specificity. It has two parts, sensor and transducer, which detect the biological signal and transform to digital signal for easier monitoring. Silicon nanowire-based device is unique as it has single crystal nature, mechanical flexibility, and high surface areas compared to other device. The small sizes of silicon nanowires make their electronic and electrical properties strongly dependent on growth direction, size, morphology and surface reconstruction. As the wire diameter decreases, the band gap of the nanowire widens and deviates from that of bulk silicon gradually. Controlling the band gap width can open new doors to the application of silicon nanowires in optoelectronics fields, such that both the band gap and width of silicon nanowires can be tuned to increase its optical efficiency. The possibility of tuning the band gap and width of silicon nanowires is determined by controlling the chemical composition and the coverage density of the wire surface area, and it has been regarded as an easier and effective route for tuning. Silicon nanowires have two techniques of synthesis, which is bottom-up approach and top-down approach. Bottom-up approach are either growing or synthesizing from bulk silicon wafer, which is vapor-liquid solid, oxide-assisted growth and metal-assisted chemical etching. Top-down approach are start from bulk silicon wafer and scaling down using lithographic process to desired size and shape of silicon nanowires. Silicon nanowires-based biosensor can be used in environment monitoring, which is in detection of heavy metal, inorganic anions and compounds, pesticides and acid rain monitoring. Silicon nanowire biosensor can detect the heavy metal contamination in fresh water such as mercury, lead, arsenic and so on. Silicon nanowire biosensor can detect the inorganic anions and compound which is harmful to human and animal life. These contaminants impart mild to severe short-term, long-term, or even deadly effects. Silicon nanowire biosensor can detect the pesticides which are regularly employed in agriculture worldwide, leading to the widespread contamination of air, water, soil and agricultural products. Absorption of acidity gas in rain cause acid rain could be detect for monitoring acid rain. As a conclusion, silicon nanowires-based biosensor being developed due to its capacity to resolve large number of analytical problems. In the near future, silicon nanowires-based biosensors are trending and need to improve for better environmental sensing.